Alright, so this is my second Calc 3 video. It's going to be on vectors, and basically if you've ever taken physics, you kind of already know that a vector is just something that has both a magnitude and a direction, and it typically, every time I think of vectors, and if I see vectors, you kind of see an arrow. That kind of makes sense because the direction of the arrow is the direction of the vector, and how long the arrow is, it's kind of the magnitude. And basically, here I was drawn some arbitrary vectors. Here's vector A, here's vector B, and if you if taken physics, you know that you can actually, there's a geometric way to add and subtract vectors. Here, if it's drawn like A and B, you kind of just put this vector, the tail of this vector, to that vector, and then so basically, you can draw a parallelogram to kind of connect the two from one diagonal to the other, but that's not usually needed. You can kind of just go to the vertex and kind of just draw a line kind of in the middle of the two vectors. It's kind of like an intuitive way to think about it. And basically, but usually in calculus, it's more algebraic, for lack of a better term. And usually, instead of just doing this way, we kind of go with the written unit vector notation. And basically, you could specify a vector based on its components. And since we're doing calculus 3, I'm going to be really focusing on 3D vectors. Of course, you can have an n-dimensional vector, but that's more of a linear algebra kind of thing. And so I'm not really going to get too much into that. So basically, you can write, the way it's typically written as you have, you can have 1, 4, and 2. This is an arbitrary vector I came up with. And you can also write this as I hat, 4j hat, plus 2k hat. And basically, these I, j, and k's are unit vectors. And basically, unit vector is kind of like, essentially unit length 1 in either direction. And, I is associated with the x, j is associated with the y, and k is associated with the z, typically. That's the way it is typically. And so for B, I've drawn 2, 7, and 3, and you can write that as 2i hat plus 7j hat plus 3k hat. And of course, if you have the negative of the components, you put a minus sign in front of them. It's not really anything too fancy. And basically, you can obviously do vector addition, kind of like what I did here. And of course, don't take these numbers to be representative of these two vectors. These are just like arbitrary numbers I came up with. But basically, this is the same. The concept is basically the same when you add the vectors. So basically, you have A plus B. You have 3, 11, and 5. And so, because you take this component, add to this component, add to this component, basically you're just adding, the j's get added, the k's get added, the i's get added. I did that in a weird order, but that's kind of what you're doing. You kind of just think of all the components, add them together, and then put them in their necessary location. So this can also be written as 3i plus 11j plus 5k. And to subtract vectors, really, you can think of it as adding a negative of a vector. So basically, what you can do is, you have, b, the negative of b is just going to be negative 2, 7, 3. And so really, when you do a plus negative b, that's not what I wanted to do, plus negative b, kind of messy, but basically, you kind of just add the negative of each of these. So you're going to have 1 minus 2 now, and so it's going to be minus 1, and you have 4 minus 7, don't know why I didn't put the minus sooner, so it's going to be minus 3, and then 2 minus 3 again, you get negative 1, and so that would just be a minus, or minus b, which is the same thing as a plus negative b. That's the way you subtract vectors. And basically, you may think it's kind of like not really a calculus-based concept, but actually it is, because towards the end of the series, I'm going to be talking about vector fields. And basically, I've drawn over here what a kind of a vector field looks like. Let's just say we have some kind of sphere. You have a bunch of arrows pointing in either direction. And for, again, those of you taking physics, for like magnetic flux and things like that, it's very important to understand that's kind of a vector field. You kind of have like every point, there's like, a magnitude and a direction. The field is not the same at each point, and that to get to that, you have to really understand what's going on here. And so basically, there is a use for it in calculus. It's probably not always easy to see right away when you kind of do this. You may think it's kind of like, off the beaten path, so to speak. Basically, that's kind of what they're useful for that, towards the end, where it's kind of like more vector calculus-based problems. But that's not happening for a long time. So basically, that's pretty much an intro to vectors. Next video, I'm going to be talking about kind of like multiplication of vectors, which is really like the dot and the cross product, and so that's a good stopping point for now. And I'll see you guys in the next video.